Hello learners, today we are going to be looking at algebraic functions, but we are going to be focusing on hyperbola. We are going to be looking at graphs. Hyperbola. This is the graph, hyperbola. Now, hyperbola, it is in the form of y is equal to a over x minus p, can either plus or minus, plus q. This is the graph of hyperbola. Now, the x minus p is equal to 0. Therefore, we solve for x, it will give us a p. What am I doing here? Because I just went straight to it. This is what we call vertical asymptote. Vertical asymptote. This is the line where this graph, it won't pass. We call it vertical asymptote. Now, what about this one? What does this q represent? Because p is talking about vertical asymptote. What about q? Y is equal to q. This one, we call it horizontal asymptote. Horizontal asymptote. Now, you can be hearing about these issues of asymptotes. What are these asymptotes? Let's talk about this value of a. Let's talk about the value of a. Remember class, if the value of a is greater than 0, the shape of the graph, we're going to look at the shape of the graph. This represents horizontal asymptote and this one is vertical asymptote. The graph must be drawn here. Remember, hyperbola, it has two curves. And another curve, it must be drawn here. This is the format of this hyperbola, the way you must draw it. Now, this is under shapes, né? Don't forget. This, I'm talking about shapes. The first one, now let's look at the second one. Let me put it here. If the value of a is less than 0, where do you expect your shape? So meaning that this is your vertical asymptote, horizontal asymptote, the curve, it must be here, another one, it must be here. So this is how you must be able to interpret your graph, because every time this value of a have an influence and the value of p and q, those are our asymptotes, you see. And remember class, we have this thing called domain, you see. Domain of the graph and also the range of the graph. Remember, every time the domain of hyperbola, it does not change. What you know is that x is an element of all real numbers, but the x must not be equal to what? To the vertical asymptote, you see. And then when we talk about the range, y is an element of all real numbers, but y must not be equal to the asymptote. Meaning that if you know the value of p, you already know your domain. If you know the value of q, you know your range. So these are the formulas that we use when we are describing the hyperbola. Alright, let me proceed here. This is the graph. Now, when you sketch the hyperbola, when you sketch the hyperbola graph, when you sketch the graph, sketching the graph, what are the things that you need to be considering when you are sketching the graph? The first thing, you look for asymptote. That's the first thing. You look for asymptote. And then the second thing, you determine your y-intercept. Where there's x, you replace 0 in your equation. You solve for y. And then the next thing, you talk about x-intercept. Where there's y in your graph, you replace by 0. These are the steps you are following when you want to draw the hyperbola. You see? Sometimes you can talk about axis of symmetry. Axis of symmetry or symmetry line. You see? Symmetry line. What do we know about this symmetry line? So this symmetry line, let me just use an arrow here to show you. The one with a positive gradient. The one with a positive gradient is in the form of y is equal to x minus p plus q. Remember this p and q, these are the same p and q, vertical asymptote and horizontal asymptote. And remember the one with a negative gradient. The one with a negative gradient is y is equal to minus x plus p plus q. These are the two equations. Sometimes you'll be asked, or I can even ask you, determine the equation of the axis of symmetry with a positive gradient. You use this formula. Determine the equation of the axis of symmetry with a negative gradient. You use this formula. You see? These are the steps where you want to use when you want to draw a hyperbola graph. Alright, let me try to get an example and show you how to draw this graph. Let's get an example and see if we're able to draw the hyperbola graph. Alright, example. Sketch the following graph. Let's sketch the following graph. What do we have? Y is equal to 2 divided by x minus 1 plus 3. Look at the graph. Y is equal to 2 divided by x minus 1 plus 3. What is the first thing that you look for? Asymptote. You see? Asymptote. Okay, before we look for the asymptote, let's talk about the value of A. Look at this A. The value of A is greater than 0. So because our A is greater than 0, we know that the type of the graph, we must find it here, this shape, and another one, it must be here. This is the type of graph I'm expecting. Now, I'm going to look for asymptote. What is the asymptote of this graph? A point or a line where graph will not touch. Remember I said when you solve this one, you just write x minus 1 is equal to 0. Therefore, the value of x is 1. This is the vertical asymptote. The one for y, you just copy it the way it is. Y is equal to this. So this is the asymptote. Now, let's go to the next step. I'm going to look for Y-intercept if x is equal to 0. Therefore, I'm calculating the Y-intercept. I'm going to replace 0 where there is x. It will be y is equal to 2 over 0 minus 1 plus 3. Therefore, you press your calculator here. When you press your calculator, you get y. So meaning that your 1 is your y-intercept. Now, we're going to calculate our x-intercept if y is equal to 0. X-intercept if y is equal to 0. I'm going to replace y by 0. I'll get 2 over x minus 1 plus 3. Therefore, I'm solving for x then. When I solve for x, what will we get? We're going to get minus 3 is equal to 2 over x minus 1. Therefore, we're going to multiply. You see? Cross multiply there, you get minus 3x plus 3 is equal to 2. Then minus 3x is equal to, let us solve there. What do we have? Minus 1. Then we divide both sides by minus 3. The value of x is 1 over 3. So class, now we have our asymptote, we have our y-intercept, we have our x-intercept, we know the shape of the graph. So let us draw the graph. After having all these things, let us draw the graph. Let me create a space here in the middle to draw this graph. Let me create a space to draw the graph. Alright. This is, remember your asymptote, it's x is equal to 1 and y is equal to 3. Your y-intercept, y is equal to 1. So the first thing, class, when you draw this graph, start with asymptote. What is the asymptote of this graph? X is 1. So meaning that I'm going to have my broken line representing asymptote. Your y is 3. So I'm going to use broken line. So these are asymptotes of the graph. Therefore, what is your y-intercept? 1. Intercepts, I represent them by a dot. Your x-intercept, 1 over 3 somewhere here, I represent them by a dot. So when I join here, I'll draw that shape. You see? I'll draw it like this. Remember, according to the value of a is greater than 0, I must have another one here and then another one there. The first quadrant of the asymptotes and then the third quadrant of the asymptotes. This is where we draw, this is how we draw the hyperbola graph. When we say draw the graph, you must be able to draw it this way. Alright. Now, axis of symmetry. Look at this one. Axis of symmetry with a positive gradient. With positive gradient, y is equal to x minus p plus q. I want us to just solve this one. What will be the value of p? We know it's 1. It will be minus 1. Our q is 3. Therefore, when you press a calculator, you are going to have y is equal to x plus 2. So this is the hyperbola graph. And this is the axis of symmetry with a positive gradient. You can try to do the one with a negative gradient. So this is hyperbola. Make sure that when we talk about hyperbola, you know how to draw it. The first thing, asymptotes, Y-intercept, X-intercept. You know the axis of symmetry, you must be able to draw them there in the graph. Thank you so much. Don't forget to subscribe as we are going to be uploading more videos to assist on functions. Thank you.